I think people hi everyone, welcome to the 80th MedAI Group Exchange session. And this week we have Elliot Bolton from Stanford CRFM here with us to speak about his work on foundation models for biomedical Q&A. Elliot is a research engineer at Stanford CRFM, where he's working on language models. Currently, he's working on a large-scale open source foundation model for biomedical NLP. Elliot has helped build and maintain various open source Stanford projects, including CoreNLP and Stanza for nearly a decade. So thank you very much, Elliot, for joining us today. And before we start, do you have any preference on how you would like to take questions? Can we interrupt you in the middle, or do you have designated breaks in your talk for questions?
It's fine to interrupt me. That's fine.
Okay. So everyone, let's try to make the session as interactive as possible. And without further ado, let me hand it over to Elliot.
Great. Hi, everyone. It's nice to meet you today. Just one moment. Is the slide deck up?
Yes.
Great. Okay. So hi, everyone. I'm here today to talk to you about foundation models for biomedical QA. And I'm a research engineer at Stanford CRFM. And I'm just going to walk through kind of the landscape a bit and talk about our recent model that we released. Before moving on, I just wanted to acknowledge the Biomed LM team, which was a large collaboration, including myself and multiple students and engineers at Stanford, and some engineers and leaders at Mosaic ML, a machine learning startup that is working on efficient deep learning training. So that's the team of people that worked on this model. Just to start, I thought I would kind of paint the picture of what's been going on lately in the landscape of large language models for medical applications. So there's been just tremendous progress lately as of December 22. So this tweet is an example of a Google engineer after ChatGPT had come out. This tweet was about just handing an example USMLE to ChatGPT and showing that it could get a passing score on it. And then a few days after that tweet, we released Biomed LM on Hugging Face, and that's a 2.7 billion parameter model that is able to get state-of-the-art results on the MedQA biomedical NLP task, which is the kind of the standard we were using as we were designing the model. And that was around December 15th. And then the MedPalm came out on December 26th. So 10 days later, we had this major release of MedPalm, and they were able to get a much higher score than us on that same benchmark. So it took about 10 days for our state-of-the-art number to go away. And then as we head into January, there was a lot of buzz and interest in ChatGPT being applied in healthcare. And then I think the world really just dramatically changed again on around March 14th with both MedPalm 2 getting announced, and that set an even higher score for the MedQA task. And I mean, GPT-4 has had an array of impressive results on these benchmarks as well. So that is kind of the landscape there. And as we keep moving forward, as we move forward in discussion today, I kind of wanted to have people bring up their thoughts about potential applications of large language models in biomedicine. I think that clearly on a high level, like some areas, there's many areas, but areas that stick out to me include, I think a really major theme in discussions I've had has been automating a lot of routine kind of information tasks, both information retrieval and communication. I think another area could be just helping researchers uncover new biomedical knowledge. And I think that people feel this could definitely be applied to directly in the patient care process as well. That could look like, there's so many specific applications that these models can do, and we're just getting started. I think summarization is extremely popular when I talk to people. So both, being able to summarize 10 PubMed abstracts that are on a range of drugs for treating a condition, or getting a succinct summary about patient records. And you could imagine all sorts of question answering applications, ranging from consumer health questions, about what do these symptoms mean, to you could imagine a biomedical researcher talking to some kind of a chat bot and having, asking really precise, detailed questions and getting, new insights from the billions of pages of research. And I think some people are even in the further future, people are actually talking about using these models to like directly support medical, I don't know that today is the day. I don't know it's ready for that level, but I think the longer term people see it as literally helping guide decision-making processes. So as we, I'm hoping at the end, I want to give people, I'm going to go through my content a bit, but I'm hoping at the end that we can talk about these kinds of questions. What would you like to see in a biomedical ChatGPT? And we really want, as we design for future models, we would like to understand what the real practitioners want to see. And another thing to think about is, practical questions like, what kind of model can, you use? Like, what's too large of a model? And what kind of tools do you wish you had for working with these kind of models? So I'm going to return to this slide at the end, but these are the kind of questions I'd love to get some, community feedback. So moving on, I was going to start talking a bit about some of the biomedical QA space. So this is an example of the MedQA task. It's basically derived from the USMLE, and it'll present kind of a patient scenario and a collection of, clinical observations. And then it will give you, a collection of multiple choice options. And then the task is to select the correct option. So this graph really shows kind of the change that has happened on this task in the last year. So, or I'm sorry, since November. My apologies. That's not the last year. That's since November. So since November, when Dragon was released, that was scoring 47.5 on this task, and MedPalm 2 has gotten it up to 85.4 since November. And so, you can see briefly for one moment, there's our little moment of progress, and then like it was swamped literally 10 days later by when the large model started getting applied to these problems. But as you can see, it's just kind of stunning. And it's kind of just an amazing milestone that, an artificial intelligence system can read this paragraph of text and, you know, select the correct answer based on it. So I wanted to also bring up a few caveats though about kind of these academic benchmarks for biomedical healthcare and biomedical question answering. So, you know, this specific task, which is showing up on a lot of graphs, and you'll see it, you know, on this Google Health graph in the left side of the screen. This task isn't quite officially USMLE, though other people have published works about official USMLEs and shown these models getting, you know, good scores on them. Back in December, there was a lot of media excitement about MedPalm kind of getting 92.6%, you know, approval on its answers, but they were, you know, compared to like a similar number for human clinicians, but the kind of questions they were talking about in that case were like, what do night sweats indicate or something like that. So it wasn't exactly like, you know, that didn't necessarily mean deep, sophisticated medical conversations. And something I think you should think about when people are talking about these kind of medical question benchmarks is that sometimes the data that is in the question benchmark could accidentally end up in the training set for the model. So they may be getting kind of artificial. If you've seen the test and the answer to it in the training data, that could contaminate it. And there are measures taken to prevent that. But that is just something to think about, is that that can end up happening at times. So did anybody have any questions about that, or before I maybe move on?
Can I quickly ask?
Yeah, sure.
So I was just curious. There's this recent work called Almanac, right? Which is how do you surface questions on medical guidelines? So I was just curious. Guidelines often differ by country, right? Like if you in the US you have NCCN, like cancer therapy guidelines, right? What chemo agent to use for what grade of cancer and what tissue origin of cancer and all that. So I was just wondering, they might differ by country. So just kind of peeking into the future, do you think medical AI models would be like tuned to, would there be like a separate deployment or version for each country to handle guidelines, or it would be something as simple as, you know, asking the user for what country do you live in or something? I was just curious, like in terms of regulating and legal implications of, you know,
I
all
think
this.
I would, you know, my opinion of that is that they will just train the model to know every guideline for every country. And then if the user will request, because you already look at the way like GPT-4 works, and, you know, it seems capable of taking a question like, you know, what would this guideline be in this country, and changing based on what you supply. So I would think the future is definitely just one model. I mean, it's a, you know, in the short term, over the next couple of years, people that want to get an application completely working correctly will probably customize it for their country and their situation. But I think GPT-4 demonstrates that over time, I would fully expect, I mean, maybe say it's a web application, it would just add into the prompt, like, you know, this is the background country for this question. And then it should, you know, get it right. And they'd probably just train, you know, the trend seems to be just training general models that can do everything. And that's sort of just a detail you need to add to the question. And that might be done automatically for the user. That depends on the implementation details of the application. But I certainly think if you said, answer this question, and by the way, make it relevant to this country, it would change its output based on which country you chose.
Right. And you would also need to, like these guidelines get updated every couple of years, right? So there has to be some sort of pre-training, right? To take into account the updated guidelines. Like, let's say if the screening was every 9 months earlier and now the recommended screening frequency is 6 months, the model needs to get updated when they change, right?
Yeah. I mean, that's like an open question about the implementation of these things is, how do you integrate updated information? And like, unfortunately, one part of this is that, things are getting really closed down because of the competitive landscape for the AI models. So we don't really know what they're doing, but it looks like, GPT-4 is in some way, they must have some plan for like giving it fresh, updated information. And some of that might involve your model actually directly retrieves the documents and then reads them and works on them. That's kind of like the most obvious plain way you can think of to adding updated information to your system. So if the model actually part of its process is it issues a query to a document database, it would get like the latest thing, or it would understand, oh, I want the one from last year, I want the standards from last year, I want them this year. And future models would understand that presumably, and it would alter its query to get, that's absolutely one way to do it. The other way is going to have to involve open research about how to directly update a model in real time, which is like an ongoing, research question. But a very simple, the most basic way you could do that is part of the application is the model actually directly issues queries and gets back documents. It reads those documents and it uses that as input to its response. So then all you have to do is put in extra documents to your database to update the information of it. But that's a great point. Like these systems being kept up to date is a very hot topic and something that is actively working. And I'd say either the community needs to do research about how to just directly update the models to understand the last 9 months of content that's happened in the world, or they need to use tools, and part of their response process needs to be issuing a query, getting back provenance, getting back documents that justify what it's saying, and basing its final response to you on real documents that it's retrieved.
Thank you so much.
Great. Did anyone else have any questions, or?
I think we can move forward.
Okay, great. So, another, I think I just showed you this graph, and yikes. I mean, there's us in the lower left, and I mean, that's just, for a moment we had a moment in the sun, and then it just like all these models on the right of this graph are just like hundreds of times larger than our model. So kind of one of the questions we want to ask is, how can smaller models compete ever in any events at all? Or is it just, at the moment, is it just goodbye and don't even bother? And I think that if you really wanted to focus a larger model on these kind of tasks, that's what's always going to be the best performing. But the trend with these larger models is they're very expensive to train, and there's a lot of work that goes into making them. And it's not at the moment, people are not taking a huge 500 billion parameter model and fine tuning it to produce performance on a very narrow specific task. So one way that I think smaller models can compete is if you take your small model and you just super train it on a lot of task following data, you can kind of get comparable performance to these larger models. And I think that's kind of one of the main insights I picked up from working with our model, Biomed LM. So there's a great data set that came out last year called MedMCQA, and it's this is kind of a typical question. It covers a lot of different categories, and it can have something that is sort of in the space of like a real, fundamental biology knowledge question, or it can have something more like this, which is kind of similar questions to the USMLE. And this data set has hundreds of thousands of questions, which is like a massively larger training set than these other tasks that we've worked with have. And it's based on questions from medical exams in India, and it covers just a wide variety of topics. And each question also comes with like a small multi-sentence explanation, which is a really cool signal that you can use in training models. And when we trained Biomed LM on this task, we're actually able to surpass the zero-shot performance of Galactica, which was a recent science-based model, and we were actually able to get pretty close to competitive results with the recent Palm model that I just discussed a little bit ago. Now, I guess this graph kind of shows the merits and the limitations of this approach, because I guess, as you can see yet again, GPT-4 just reigns supreme. It's possible that I don't fully know if there's contamination in the GPT-4 training data, because we don't know what training data they used. And there has been some speculation that GPT-4 just has been contaminated and it's seen these test questions, but I have no reason to believe that one way or the other. So, but I still think that if you look kind of back to this graph, it's like that's the gap. The middle entry is the gap that we're kind of dealing with. And it's cool in the case when we actually had a large scale training set in the order of hundreds of thousands of questions, we can kind of get a simulation of what that much larger model can achieve. And another cool situation is the MMLU genetics test was another test that we saw some pretty positive results on. And that's just kind of a like standard college medical genetics test that here's like a typical question you would see. And, once again, our model is actually kind of relatively in the same space as these much larger models. And then once again, GPT-4 is getting like a 92. So we're not entirely clear if some of these test scores are so high, people are wondering if the test questions just are in the training data for GPT-4. That's unknown. But I think both of these graphs hopefully show that, if you give Biomed LM, which is 2.7 billion parameters, if you give it a large training set for your task and you focus on a much more specific task, like just answering kind of questions that look like this, it can actually start to simulate the results that these huge 500, so Biomed LM is 2.7 billion parameters and Flan Palm is 540 billion parameters. So, the Flan Palm number is the number it gets sort of after it's been tuned to generally perform on tasks. So if you fine-tuned Flan Palm straight out just to do this one task of answering these kinds of questions, it would crush us again. The insight I'm more trying to make is that, or reveal, is that if you take a very small model and you train it on a very narrow focused task, you can kind of get the same kinds of performances on that task that the drastically larger models can get. So I think that that is a formula for small models to be useful. And, you know, we saw a lot of I've seen a lot of benefits so far in my experimentation on training Biomed LM on this MedMCQA data source. And it's just a fantastic, really neat data source for these kind of biomedical question answering scenarios. And I think it shows that a small model can be competitive with large models that are just performed to do general things. But caveat, if you really wanted to take your large $1 million model and focus it on this task, it would, you know, certainly probably be the state of the art on that kind of thing. So before moving on, I just wanted to take a pause for a moment, and if did anybody have any questions or comments they wanted to make?
Sure, I can start with a question here. We're talking about making, like, what's the utility of small models when there are such large models available. Have you thought about making them kind of more trustworthy? And by being trustworthy, I mean where you can understand or backtrack the reasoning behind an answer. Because explainability has always been an issue with any AI model. And I think with large language models, you can say, okay, there is this amazing performance on USMLE task or any other Q&A task. But we also have, you know, a known behavior of hallucination from these, you know, large language models. So do you think that small models, they can kind of make their mark as being more understandable, more transparent in how they are getting the answer that they are getting there?
I think that a better way to, like, the way I would think about it is, I wouldn't really say that like addressing that issue is a strength, or like small models don't really have an advantage, you know, an advantage in that, because I kind of think the first way I think of in addressing an issue like that is using retrieval and pulling out provenance for the outputs that you're making. And then that turns into a question where you kind of actually need a larger model to leverage that, I think. And so what I mean is, if you pose a question to the model, I think something that might make you feel more confident about its responses is, did it go out and get explicit paragraphs from trusted documents? So if you throw PubMed or medical textbooks or whatever you will into into a search engine, if you index them, and then part of your model's final process is going out and issuing queries to that index, then you could use the source material that you retrieve to enhance your answer. And that actually, you know, like a straightforward way that I think of to do that would be, you know, and I speculate maybe GPT-4 could do things like this. These models have sort of like an input context window. So you could imagine part of your algorithm is you take the question and you turn that into, like, get me back trusted passages of text from trusted documents. So a published PubMed paper or something like that. Get back this context for me. You put that into your input window and then base your final answer on these notes that I've provided you from trusted sources. And then, but doing that, what I just said, kind of involves a larger model and a larger context. And I mean, you know, that's how I would probably address the hallucination issue. And that being said, you know, it is easier to train smaller models to be more focused on that. But I would imagine they want to train the larger models to be, you know, focused on that issue as well. I mean, my personal opinion is part of the solution to the problem you're bringing up is to retrieve passages of justification. And another part of it is, yeah, people do research into provide an explanation for your answer. So don't just like pick a multiple choice option, but write, you know, a paragraph. And a small model could be helpful in that you might be willing to spend the time and money to fine tune it, to rely on these explanations and stuff like that. But I think even large models, they want to apply those kind of techniques. On the one hand, some people may be a purist and they just want the model to do everything, and OpenAI may be figuring out ways to make that happen. But it seems like it's got to be helpful to get back passages of text that are from trusted sources, like a known medical textbook or a PubMed document, like really high legitimacy sources, and then use that as shaping your answer. So you could just put the passages into the input window and say, answer this question, here's the question, here's some notes from these sources. And that becomes more possible as the context windows are starting to expand. Like our model has a token limit of has a context window of 1024, but I mean, I think GPT-4 is at 32,000, and that's part of the active research, is just techniques to expand that context window. And then when you expand the context window, you can do things like answer this question, here's a page or two of notes that I got from trusted sources, and then the user, and integrate these notes into your answer. And then the user, I think part of solving the problem that you're talking about is being able to show the user, link back the reasoning for this answer to specific evidence from really high trustworthy sources. And part of it could be like telling the model, show your, explain why you answered the question that way, and write out an explanation. And then the user could go like, what? If the explanation isn't very good, they can, be skeptical of it.
Thank you, Elliot. With this discussion, I think we don't have any more questions right now from the audience, so we can move forward.
Okay. So I want to just kind of briefly describe like the Biomed LM model and just give people some details about it now. So that previous section was just trying to kind of show applications of it in the test space and give you some details about it. It's basically a GPT-style model that just predicts the next token. It's 2.7 billion parameters. So that's the kind of thing last year we sort of had the ability to train versus, the ones you're reading about in the news have hundreds of billions of parameters. And that's a big deal and influences performance a lot. And it has a custom tokenizer that's designed for the biomedical space, which is just trained with the standard Hugging Face tokenizing library. And we trained this model on 300 billion tokens of PubMed abstracts and the full papers. And we did that with the help of Mosaic ML, and we used all of their tools and did this on their cluster. So here's like a graph kind of showing, we did see kind of continuing loss for the model on both the training and validation sets. And I think some of the insights we learned while training this are that you can get, you can improve your performance on domain specific tasks by building a specific model for that domain. Having a tokenizer that's for your domain can help. And, it was, as these graphs show, like the whole training run, it was helpful to continue training it. And we saw better downstream task performance as well as we kept training it. And for just to hopefully clarify that to the audience, this is a graph of the probability that the model is giving documents from PubMed as time goes on. And so the question is, are you training it too long? Are you just going on and on and on and it's not really doing anything? And so these graphs going down are a good sign because they show that it's continuing to assign more probability to a PubMed document, meaning it's getting a better understanding of what PubMed text looks like. I wanted to show like some advantages. So this is a little more addressed to practitioners that want to build their own models. Some of the advantages of having these models have to tokenize the text as a first step. So they turn the text. If you give a paragraph, the most obvious way you could tokenize it is just splitting on space, but there's more sophisticated means that you want every token to kind of be like a word. And when you have just a plain, if you look at this list of words that I have in the left column, you can see some kind of standard technical terminology that's in the biomedical space that's not getting a full token with the standard GPT-2 tokenizer. And that's because, you know, there's a limit to the vocabulary size for GPT-2 versus our model versus, well, there's always a limit to the vocab size. So the tokenizer did not see it worth. The GPT-2 tokenizer is the one you use for like a plain English model in the open source world. And it doesn't turn these complicated terms into one word. It sees them as these smaller components. Was there a question?
No, I believe it was just some noise.
Okay. Sorry. Okay. So the takeaway from this graph is just that if you use a biomedical tokenizer, it'll actually give a token to like much more sophisticated biomedical words, whereas the English one those words are much less common in like just a general English document set. So it'll be forced to represent those words with several tokens. And the way tokenizers work is they create a token for common words, and then they have sort of small subword pieces that they put together for rarer words. And so that's what you can see going on with that right-hand column. So that kind of is why using a biomedical tokenizer can be helpful, because the information for those words can be stored in the embeddings for one token versus several kind of vaguely related tokens. And this graph is kind of cool to show the impact of really having a targeted, specific focus on the biomedical domain versus the general English model. So GPT-Neo 2.7 is a general English model, and you know, Biomed LM is trained really focused on the PubMed articles, and you can see way higher scores on the biomedical question tasks, BioAsk, PubMed QA, and MedQA from our model, which is the right-hand columns. And that's just showing the advantage of, instead of training a model on plain English. So GPT-Neo is just trained on, you know, general web documents from around the internet that are in the English language. And Biomed LM is trained on the PubMed abstract. So I feel like this graph kind of encapsulates the value of pre-training on the domain text that you're interested in.
Elliot, I think we have a question from the audience.
Sure.
Ashish, you want to go ahead and ask?
Yeah. In the same vein, you know, you compared GPT-Neo and Biomed, that, you know, GPT-Neo is all English text and Biomed is specifically biomedical text. I was just wondering aloud that, again, maybe gazing into the future, could a model trained on purely, let's say, cancer data outperform a medical AI model which is trained on all pathogenic diseases, and, you know, something trained purely on cancer data outperform a model trained on all kinds of diseases? Like, you know, a model specialized.
I think there's, you know, it kind of remains to be seen what the future development is, but I definitely think it depends on if there's a large enough set of documents for your, I mean, you're basically saying we have the biomedical domain, and that could be specialized. You could make that look like a, you know, the biomedical makes English look like a specialized, it's specialized relative to English. And then there's many things within biomedicine that could be specialized relative to the overall universe of biomedicine. So I definitely think there's merit if you're really focused on a specific sub area. If you have a large collection of documents that's in that sub area, there seems to be merit. Yeah, I think there would be merit to pre-training on that for a bit, just as a general starting point, because you know, pre-training seems to imbue your model with the knowledge of that corpus. So you know, I would expect if you took Biomed LM and say you had 100,000 papers on a specific topic area, you know, virology or something. And I mean, I've been thinking about fine tuning Biomed LM on a genetics textbook to see if I can make its score go up. So I think that's a tool in your toolbox to fine tune. I don't know, like the retrieval approach may, you know, make that less necessary, because if you just have a general language understanding model, it might retrieve the contents from the genetics textbook and then use that as its response. But you know, that's kind of open research. But I would imagine there is value to also just directly fine tuning your model on the kind of text that you are interested in. I definitely think there's merit to that, and that, as this graph is showing English to the biomed, and I think what you're saying is very true. You could keep going with that and really target a narrow area of biomedicine, a narrower area of biomedicine.
Thank you.
And building on the same question I have, Comment, do you think it's going to, there will be a relationship between how specialized your model is, like from plain English to biomedical to, let's say, only cancer, and the size of the model that you would like to train? Because I assume that if you keep looking for rather more specialized data, a more specialized field, your training data set size would decrease. So do you think that would affect the size of the model that you could you know, justifiably train from the given data?
Yeah, I mean, I don't get the sense that they're interested at the moment in pre-training GPT-4 on narrower and narrower data sets to make like a biomedical GPT-4. I think because really what seems to be the trend is taking your domains. If you're really getting up to that large scale, I feel like the trend is a lot more directly building a general model that can understand text, and then putting meaningful content into the context window to in context prompt it to, you know, write meaningful responses. And I don't know, they're probably the algorithm they're looking for is train a general model that can perform well. You might need to specialize it a bit so it can process scientific technical text. So that might involve pre-training it longer on a large domain of, you know, I could imagine you take a GPT-4 scale model and you train it on PubMed for a while to make it really good at handling medical text. But then if you want to keep specializing, I think you would probably be more inclined to retrieve kind of special, you know, key passages that you need for the response at a given moment, and then put that in the context. But I think that, and if, like, one thing that smaller models have going for them is you could actually just justify, you can try it and find out what happens if you're like, I want to even fine tune it further to be really specialized on this domain. So it's not so much, you could try that with larger models, and, you know, like, I guess I don't know, it's unknown if this trend of really focusing the document set will start to not have the same kind of, I don't know if the dynamics of doing this will work at that scale, but it could, you know. So, but I think the issue is just it's so expensive to train those large models that they're not keen to do that. And practically speaking, if you're in the smaller space, you know, we can try that. We were, you know, an academic lab was able to try that and show that you can kind of get competitive performance with a larger model.
So basically, it's about, you know, the size of the training data set versus like what you can put into your context windows. If you're working with a larger language model and you need to make it specialized, you would probably focus more on what you're putting into the context window rather than, you know, limiting the training data sets. That's kind of the gist that I get from your discussion.
Well, I think, like, right? I mean, I feel like if I was trying to get GPT-4 to do something specialized, like I guess I would experiment with like fine tuning it for a little while if I had the money and I didn't care. I mean, I could try. I don't. Are you talking about things that have like 500 pages of what kind of, how specialized are we talking? Like 500
It
pages?
just kind of came up in the discussion, like if biomedical, of course, it's a specialized domain as compared to plain English, but then cancer is a more specialized domain. But if you want to go even further, like would you, specialize for just breast cancer? Like, I mean, there
I
is no
kind of
limit.
think
You
the
can just keep
future.
making it more and more specialized.
I think the future is when it gets so specialized that you could put a huge amount of meaningful content into the context window. That's what you do. And I think that's the direction it's going. Is like, so if it's so large that it's not practical to put it in the, I suspect the future is you could dump the whole genetics textbook into the context. Like not today. I mean, I don't mean tomorrow, but I kind of think that's like where it's going. And if it's so large you can't do that, then you would probably be interested in doing some fine tuning runs. And what I'm saying is like a smaller model, it can be beneficial to just jump to that fine tuning step because you can afford it, you know, and you just don't mind doing it. But and if you had the money, you can do it for increasingly large models as well. So maybe to summarize what I'm saying is, if it's small enough, you could meaningfully imbue your response with domain knowledge by putting it in the context window. I think that's preferred. And if it's a large enough area that, you know, you can't do that, then the next tool you have in your toolbox is to like fine tune for a while on that even narrower domain. And then, yeah, you would have a model that hopefully is better on that narrow domain. But that has to, I mean, that has to be borne out through experimentation.
Okay, thank you very much.
So to wrap up, kind of talking about the Biomed LM choices, I feel like there's a few things we could do better in future models. Like, I mean, it's great that we have the biomedical tokenizer, but on the other hand, like, if you want to try the formula of just taking there's a lot of new models that have recently come out more at the 7 billion scale and larger that are plain English models. And it's probably, I'm kind of suspecting it would be better to just fine tune those models and like more cost effective than to start from scratch and use the biomedical tokenizer. We made the decision to train on all of PubMed and not just the abstracts. And I think that ended up making our generations a little bit less like fluent because there's a lot of just like tables and all sorts of stuff in PubMed papers. So that could be a warning flag. That could be a drawback of training on the full PubMed papers. And, you know, just due to cost constraints, we were kind of limited to a 1024 context window. And I think we should have used some of the modern choices like rope and alibi, because that lets you have a flexible context window when you fine tune. So those are some things I'd like to improve in future versions of Biomed LM or future models we train. And I want to just kind of wrap up with some selling points of Biomed LM. It's you can customize it. The code in the model are open source. You can download it and have your own copy of the model. You can keep fine tuning it in all the ways we've been talking about today, and you can keep it, you know, you could fine tune it on your health records at your hospital, any task you care about, and it's really easily integrated with Hugging Face. I mean, that has great privacy security implications because you can just download it, keep it on your private network, and never, you know, if you have private data that you need to follow the laws around, you can keep your model on your private cluster, and you can do all the training and inference in-house, and you don't have to talk to an external service. And I think, you know, it's an affordable option for people. It's only 2.7 billion parameters. You can, you know, it's cheaper to run the inference and the training of it, and it only costs us you know, compared to the millions of dollars that the ones you hear about in the news are, you know, this only was about 40,000 on the Mosaic ML cluster, And I was able to fine tune this on some tasks, basically just on one GPU with 20 gigabytes of memory. So those are the 3 key points selling points I wanted to make about the model, that you can customize it. It can be good for your privacy security, since you can just keep it on your internal cluster, and it can be an affordable option for people. So with that, I'm just gonna switch over to answering questions now, and possible. I was hoping we could discuss possible use cases of these models in the last 10 minutes or so, or any thoughts people have around this space.
I had a couple of quick
I
questions.
just want to control questions. Yes, please go ahead.
Hi. So, excellent talk. Loved it. So, 2 questions, right? So, one is in an earlier episode in this series, Vivek from Google Health AI talked about MedPalm and MedPalm 2. So, I was just, and then, Microsoft Research has been really very strongly looking at health applications of GPT-4. So, these are all on the kind of proprietary or industry side. So, and there's a lot of innovation in open source, general purpose LLMs. Do you see open source medical LLMs being, achieving comparable performance to let's say MedPalm from Google, MedPalm 2 from Google, and GPT-4? And to spur that on, do you need more in the general purpose LLMs, in terms of data sets, there is something called the pile, right? Do you feel there'll be similar data sets emerging both on the training data side and also on the eval side? Like Vivek in his talk talked about a lot of these new evals, right? And both from a clinical, like clinician, clinically relevant eval factors, and also layman patient relevant eval factors in terms of fairness and intent and all that. So do you think we need medical AI specific data sets like the pile, the medical equivalent of the pile, to spur innovation in medical LLMs?
Well,
that was what
I don't know if like PubMed is in the pile. I don't know if you mean, I'm more of a, natural language processing engineer, so I'm learning about this world. And so I've kind of learned there's sort of the biomedical, there's biomedical, and then there's more healthcare, which would be maybe like all the patient records you have at your hospital that has to be super private. Right. I think it'd be great if somebody curated more content than just PubMed, and we could play a role in that too. And we're definitely interested we're working on training larger models that are open source that can hopefully do similar. They're not going to be on the scale of MedPalm,
540 billion or something, yeah.
But we're super interested in building on that. That's kind of what I was getting at with that slide, is we're interested in building on top of the things that have just come out that are in that 7 billion scale. That I think that's kind of the future of. This was a great experience to train this from scratch model, but it's tough. The scale you have to achieve to start being competitive with MedPalm, it's kind of tough to pre-train from scratch. And I think a lot of things that have happened recently have shown you can really get some cool performance by fine-tuning on top of these base models. And so we would hope to maybe produce, help produce open source models that can be foundations for even more specific applications. But we're definitely super interested in both helping curate data, curate benchmarks, and build open source models on top of the large things that have come out. I think that's definitely, I'm actively working on that, trying to get larger open source models out there. And I think we need help from you all in the community to understand what the benchmarks should look like, because we really want like 1,000. And a real stumbling block right now is that, like, that's cool and neat that I showed you the USMLE, and that's an interesting academic benchmark, but I think the next phase of this is we really want to move into having much more practical benchmarks. And that's why we look to all of you in the biomedical healthcare community to help us understand what do people want to do with these kind of models. Because like I spent last year just very focused on getting a better score on the USMLE, but that's not, I'm finding out very quickly that that's not really, like, doctors don't want, you to just answer a USMLE question. So understanding, I think having a large suite of benchmarks that are more practical and really oriented on what the healthcare and biomedical communities want is going to help us judge these models. And yeah, I mean, I'm super enthusiastic about, because that's happening in the general English model. You'll have these 10 tasks that are kind of canonical tasks. And if you see these models come out, there'll be a table with these 10 tasks and like how you do on all those numbers. And I think we need that for the biomedical models. And so you can imagine something like summarize this patient email or something, or whatever it is, like, and that needs to be fed by the healthcare and biomedical researcher communities.
Thank you. And if nobody else has a question, can I sneak another one in? So just, this is a non-technical question. This is, I was just wondering, in your experience, like, and open it up to everyone, like, do you think there'll be one medical AI model to rule them all, or will there be like 1,000 flowers bloom, right? There'll be a Google medical AI, there'll be a Facebook medical AI, there'll be a GPT-4/Microsoft medical AI. Just kind of gazing into the future.
There will be competing models, and it'll be a battle, right? And then like it'll be an evolutionary system, and different models will be successful at different things. And then it's possible if one of them is just really awesome, it'll become the gold standard. But several people will clearly try this, and if there's money to be made in it, people, like 10 people will try it, and then we'll kind of have to see, right, as it plays out. And it's tough. It's tough to predict how like that competition will end up.
Will there be an ensemble model which will, like meta, like which will query multiple models depending on the query and all? Yeah, I just sometimes I tend to, gaze into the future, but yeah, I think we are still a bit away from that.
Interesting, Ashish. I think for that ensemble model, all of these competing models, they also tend to be cooperative with each other, right? So if you're going to build an ensemble model, all of these competing companies, it's almost like they're pooling resources. I'm not sure how that will happen, but yeah, but very interesting thought. One last comment before I think the end of the session. At the end, and I understand this direction might be limited by patient privacy concern, but do you think radiology, basically radiology report and clinical notes, do you think these will be the directions where the language models could move into, instead of being on published papers, but with clinical notes or
yeah, well, I mean, there's lots of people are doing that. There's huge interest in that. I mean, that's a definite thing that's where I've kind of learned that, that's a limitation of PubMed, is people are more interested in, there's people that are interested in PubMed version, but people definitely want a model trained and on their internal patient notes at their hospital. And people have been doing that. There's some models, there's some BERT models out that I've seen already doing that, and startups are doing it. And it's an active, both everything you just said, people absolutely want to train models on that kind of stuff. And that, but then there's a bit of a that becomes a bit of a complication because you can't open source that model if it was trained on the private data. So you have to sort of like, you can make it and it can be used internally at a large, you know, hospital or organization, but well, I mean, you have to deal with the fact that it's not, you can't, if you train something on PubMed, you can just put it out there, but I don't know what all the rules would be if you train something on your internal patient data, but that's very restrictive, and they can't just throw it up there without there being, you know, problems.
So we don't have any other questions from the audience. I think that's where we can end. Thank you very much, Elliot. I think then later we'll put it up on YouTube, and is that okay with you?
Sure.
Thank you very much.
Okay, great. Thanks, everyone.